Does it work in the back? All good? I'll wave there. That's so far away, I can hardly see it. As you can see, I started with my own blue screen, so nothing can go wrong anymore from here on. I'll be talking this afternoon about, it's all about the goto. Now, I don't necessarily mean the goto keyword in PHP, right? Hopefully none of you are actually using that very much. Maybe, that's okay. There's a good reason once in a while. So I'm Derick, I'm European. That's a lot easier to explain than my more complicated nationality status. If you want to talk about it later, feel free to come and find me. I've already been introduced, what I've done for PHP. I currently work for a company called MongoDB, and I work on a MongoDB driver for PHP. If you have any MongoDB questions, come and find me as well. I'll be here all afternoon. I like maps, I like beer, I like whiskey. I have some examples about whiskey-related applications, so I might get back to that in a moment. If there's anything you want to ask currently during the presentation, or if you think I say something funny, feel free to quote me on Twitter and things like that. You might get an answer later, or not, depending on how nice you are. But with that said, let's get started. So basically, I want to talk about 3 points this afternoon. I want to talk about a little bit about the different stages there are in getting PHP to see your script on disk, to running it and producing output at some way. And as part of that, there's lots of different stages that PHP converts your data into different data structures. So we'll be looking at that a little bit. If at any time it gets a little bit too complicated, which will happen, I can guarantee you, then I would appreciate it if you leave the questions to last, because I am a bit, wouldn't say short on time, but it's tight on time, and it'd be better to let me do the whole thing instead of being interrupted. But of course, at the end, happy to answer questions. And then we will come back to a little bit of a conclusion. All right, so let's get started. We're starting with different stages, not stages of the moon clearly, but stages of how PHP executes the script. And there's about 4 different things that PHP does. So the first thing is parsing the script. It's like PHP reads the file from disk, does something with it, parses it into something called tokens. And what all those things mean, we'll see in next slides. So those tokens, they don't really mean anything to PHP. It's just chopped up PHP script. So those gets converted by creating a logical representation out of that, by converting these tokens into an abstract syntax tree, which is a word that is really difficult to pronounce 50 times in an hour. So I'm going to call that AST from now on, which stands for abstract syntax tree. And what exactly that is, I'll show you later. From this AST, we then start creating executable code, which is executable code that we call opcodes in PHP, or sometimes bytecode. You hear different names about them, which is what the PHP interpreter actually runs on your machine, which is then the last stage, which is the execution. All right, so those are the 4 stages. So let's have a look at the first one, which is the parsing stage. In the parsing stage, PHP will convert your script into tokens. And the way how this works is that in the tokenizer, there's a big, basically switch case statement matching all the different things that, well, it goes through the script 1 character at a time and tries to associate some meaning on them. Now, in PHP, in the parser, there's different states. There's an initial state. Basically, we're at the start of the file, and we don't know what's going to happen yet, because 2 things can happen at that moment, right? You can either open PHP by having your PHP open tag, or you can just have random text in it, which is basically echoed straight away to the browser or the output. So this is the initial state. Once you use the PHP open tag, the parser or the tokenizer goes into a different state, which is st in scripting, state in scripting. And at which point it does more different things, like recognizing a dollar with a number of letters behind it gets looked at differently in an initial stage, or this in scripting stage, or in inside double quotes. So there's different rule sets on how PHP needs to break up all the things it sees, all the characters it sees, and do things with it. So some of the tokens can change these states, like the PHP open tag that I've done here, or if you have a double quotes, that is the start of the state st double quotes. There's a similar one for the now and here docs, and so on and so on. But what is important to realize is that although PHP chops up your script into all those different tokens, it doesn't actually really know what to do with them. It doesn't give them any meaning. It just sees there's some text here, there's some white space here, and so on and so on. If you want to look at that, what PHP actually does, there's a tokenized extension, which is part of the PHP core distribution, but not necessarily enabled by default. And you can see what PHP does. So let's have a look at that. So my little example script, I did tell you I was going to talk about Whiskey a little bit, is, well, what do we have here? We have a single file where I have a namespace. It has one class called Whiskey. It has a private property, and it has two methods. It has a constructor and a drink method, right? Now, from this script, I realized later that showing all the tokens of that is a bit much, so we're doing it only for the first bits that we see here. If you convert it to tokens, you can see exactly what it does, right? So it sees the topen tag, and the topen tag has some text associated with it, which is the opening tag. You have t namespace, and t namespace is your namespace keyword. Then it has a string called dram.io, which of course we know is the name of a namespace. But at this stage, PHP only sees, oh, this is a string. It doesn't do anything with that string at the moment. It just recognizes, oh, there's a string of letters here. There's some white space again. There's the semicolon, which doesn't have a token name. T-class stands for the class token. Again, there's a string behind it. Then you have T-private, and so on and so on. So basically, for every PHP keyword, there is going to be a token name, with some exceptions and some duplicates, but that's the general idea behind that. Does that make sense? Right? All right, so, of course, those tokens on their own, PHP hasn't given any meaning to them, right? So it needs to, in the next step, is going to want to recognize this stream of tokens into something that actually makes up the language. So this language, PHP, is being implemented in the scanner phase. So the scanner in PHP is written in a language called Bison. What it tries to do is, for every sort of logical things you have in your PHP script, like you have t_private, a variable name equals initial condition, it tries to match these logical things according to the tokens that have been shown. So as a quick example here, like if you start a PHP script, which is a state called top statement here, well, you can either have a statement, a equals 1, you can have a function declaration, function foo, blah, blah, blah. You can have a class declaration or a trait declaration, and a bunch of other things, but that doesn't fit on the screen. So in a previous example, although we had a namespace, we'll forget about the namespace for now, but the class declaration statement, what can this be? Well, for each of those things, there's another set of definitions, which you see in a second block here. So what it here says is that a class declaration statement starts with class modifiers. Okay, this is again lowercase, so we need to figure out what those class modifiers are. So down here, we see that class modifiers are either a class modifier, or it is class modifiers followed by a class modifier. Okay, this is a way, because of course in PHP, a class can have multiple modifiers, right? It can be both abstract and final. Well, no, it can't be, but for the scanner, it can happen that there's multiple modifiers. So in this case, for every time it finds like this token that matches, so in this case, if we have a class modifiers plus t-class, that's your class token, followed by a string, your class name, and then optionally something where it extends or implements and a doc comment. When it finds these things, then everything between the square, between the braces, the curly braces, there will be a list of statements that it then needs to do in C. Does that make any sense? So what it tries to do is tries to match logical bits of your PHP script and associate things that it needs to do in a runtime to create this AST out of. And the AST then gets used later on. Now, the file that shows this is very long, very big, and very complicated. So I wouldn't recommend you go look into this, but if you ever want to add a keyword to PHP, that's where you go. All right, so what the scanner does, as I said, it gives the meaning to these tokens, and it constructs this AST through the rules that I showed you on the previous slide. So if you really look at this, so this is the class declaration statement, at some point you see here that there's a Zend AST create decl declaration, where it then creates a class node in this AST, which I'll show you in a moment. And depending on other things, it will create different things out of this. So what you see in the first example here gets converted by running Bison on that file to the second one, where you see lots of case statements. So there's a big switch case statement thing in there that basically goes through all the different rules, and it jumps around with goto, actually. But yeah, the second file you don't even bother reading whatsoever. So yeah, the important thing to know here is that from the scanner, recognize the tokens and creates this AST, the abstract syntax tree. And that looks something like this. So the AST is something that describes the structure of your script. In each node is a specific either language construct, it can be an if statement, or it can be a class declaration. And most of those things have arguments, right? So a function call will have the name of the function or the class name. It will often have arguments that you can pass to the function and so on and so on. And those are all arguments of those single AST nodes. Similarly, if you have an if statement, the condition is an argument to the if statement. And all of these things are shown and stored in this AST nodes. What is important though is that some information gets actually lost. So if you have any comments in your code, those do not get transferred to your AST unless they are like doc comment blocks. Because doc comment blocks is something that PHP needs to preserve because you can use reflection to get back to the statements, right? So the AST needs to keep these things around. But any other comments that you have throughout your code that aren't the doc block are being discarded here. Also, you lose all the white space and things like that are all gone as well. So anything that PHP doesn't need for executing the code is going to be thrown away here. Again, there's different ways of visualizing this AST. There's this PHP AST extension on Nikita Popov's GitHub account, so you can have a look at that. And the original idea is that from this AST, because it's a very logical description of a script, a single file in your application, you can actually do some optimizations on them that you can derive from some logical conclusions. Like if you have an if statement where you do if true, then of course you don't care about the false state, right? So you could, if there was an else clause to that if statement, you can remove it from the AST because you know it can never be executed anyway, so why bother keeping it around and create code for it? As far as I know, nothing actually does that, but that is an idea behind it that you could do. All right, so from this AST, if you look at the AST parse code output, you get this much code. So from this little tiny script, well, it is very, very difficult to read, so I won't bother looking at that. Instead, there is an extra function to this AST extension from Nikita that actually formats it in a slightly different way. And if you look at this, it's actually kind of obvious what happens. So the whole script is a statement list. It starts in this case with a constant. I don't actually remember what it was, so I'll skip over that. But the main thing is that the second statement in your script is this class definition, which is represented by this AST class node. Now, a class can have different flags. Flags could be whether it's final or abstract, for example. It has a name, so there's this name element to it. Does it extend anything? No, so it says null. Otherwise, it would be an array of class names. Same thing for implements. It would be an array of classes or interfaces that it implements. And then, of course, each class itself, after the class name and flags, is a list of statements again. And in a class, as you can know, you have constant definition, class constants, you have properties defined, and then you have all the functions, right? And that's exactly what you would see here. Every of these statements will show in this STMTS element will be the list of statements that belongs to the class. So in this case, the first one with the number 0 is AST prop decl, a property declaration. A property declaration can have flags, whether it's a private property, a public property, or protected, for example. And then, in this case, the property declaration has one element in there, which is the name itself, and you see that there's no default set for them. So every little thing that PHP scanner sees gets created into nodes like this. And a more complicated one is the AST method one. Again, it has flags, it has a name, it has a list of parameters that you can pass through the function. So in this case, a list of parameters, there's only one of them. The name of this argument is name. It has no default value. There's no flags associated with it. It can't be null, and so on and so on. And then for each method, of course, you have the list of statements again that describes what happens in these functions or methods, and so on and so on. The more complicated your script is, the more complicated your AST gets. But this is sort of quite readable to figure out exactly what happens. And it is also very possible to go back from this AST back to a script. You can generate PHP code out of this later again. However, you do lose some information, like as I said, the comments that you have in your code, because they're not in the AST, you won't be able to write back because they're just gone out of this AST. All right, so to link this a little, make this look a little bit closer to what it actually does, I have this very 3-line or 4-line function. So what it says, it's a public constructor with a name, and in this constructor we set the name property to the value of name that's being passed in, right? It's not the most intelligent function ever written, but it sort of does what it does. And what I've tried to do is try to color code how the words or the strings in the PHP script, how they look like in your AST. So an important one here is, of course, it is construct, which is the name here. You got public, which is the modify public. You have name, which is the name here. The assignment here is a bit more complicated because that's what it does here, right? So there's an assignment, and the left-hand side of the assignment is a variable, this variable, with a property name. So the left-hand side, although it is a variable, because this is a property value, there's an extra node called AST prop. That is an expression again, where the variable name is this, and the property that we're trying to access of that is prop. So you get this other nested structure again for just that little part of your script. And similarly, what we're going to assign to is the expression, or rather the right-hand side of the equal sign. And we said, well, this is an AST underscore var with the name. So that's how that gets broken down. It also says there's a return type null, because none is defined, so it gets defaulted to null. All right, so yeah, a little 3-line script gets into quite a large abstract syntax tree. However, an AST, as I said, it's a difficult word to pronounce a lot in a presentation. PHP doesn't know what to do with, right? It needs to get from this AST into something that PHP can run, which is the last, or the fourth stage, which is creating the bytecode. So the bytecode in PHP are also called opcodes or oparrays. It has a few different names in different literature. Each function method or main body of a script is represented by an oparray which contains these opcodes. And each of these opcodes is an instruction for the Zend engine. So the Zend engine executes each opcode in turn. If it sees a function call, it will pause the execution of this oparray, start executing the oparray of a function. If it finds another function call, it will do that. At the end of that function, it will go back to the previous one and continue executing the opcodes in these bits. And this is very similar to assembly instructions. If you've ever seen any assembly, just curious, how many of you have ever written assembly code? That's a fair bit. That's good to see, actually, because that means that explaining the next slide is a bit easier for you. And these instructions, these opcodes, can be visualized by some tools as well. So this part of that is PHP DBG can show you that. But I've written an extension a long time ago called VLD, which will also show that. So I'll be using that tool now to visualize how those operators and opcodes look like. All right, so if you go back to the AST bit from the previous slides, where we do this very simple assignment, you see that the opcodes are generated from that are suddenly, there's a lot less of it, right? There's a fewer lines there that actually do something compared to the AST. So the bytecodes or the opcodes that are generated, there's going to be 7 of them. There's xnop, which stands for no operation. Basically, that doesn't do anything. It is still there because it is the line that had your your method definition on it. This is something that things like OP cache will throw out for you, will remove and not store, because it doesn't do anything. Then you have RECV, that stands for receive. That is the opcode used for accepting a value passed in as an argument into the function. And RECV will store an element that's being passed to the function, and it does those in order. In this case, there's only one, so difficult to see. And it will assign the value of what it's seeing in to this big exclamation mark 0. And exclamation mark 0 is a PHP representation of the name of the variable called name. So since PHP 5.3 actually, PHP will look at all the variable names that you have in a function and will convert them to a number. And then in the opcodes, we'll use that number, which is a simple index into an array, which is a lot faster than having to look up this array index for every single time it sees a variable name, which is what PHP 5.2 and earlier would do. So there's an optimization in there that's been in there for, well, a decade, PHP 5.3, long time ago. But what VLD will show you, laser, oh, there we go. It will actually show you at the start what those numbers mean, so that you can trace that back to what it does. All right, so the third opcode says X statement. That has no meaning to the PHP engine either. It doesn't do anything. But what you can do in extensions is you can hook into this opcode. This is an opcode that is generated after every statement. So this is great for debuggers to create as a trigger so that you can step over every statement. So that's something that Xdebug uses, so you can single step over statements that exist. All right, so after this extend statement, we have this assign OBJ. And this is a opcode that is created from an assignment, but from an assignment that involves a property access. So PHP has lots of these specialized opcodes to combine more complicated things into one instruction, because that speeds things up. So assign OBJ accepts a name of a variable and the name of a property. But if you look at it here, actually, you only see the name of the property. Right? The variable name is gone, because if you remember, it said this name, right? Not just name. Again, an optimization. If there's no property name there, it means use this. So we don't have to store information. There's another tiny optimization you have in these engines. Now, all opcodes in PHP have two operands. So there's a operand 1, operand 2, and a return value. And in some cases, an instruction needs 3 operands. And that is what you need for this assign OBJ, right? Because you need the name of the variable, the name of the property, and the value that you're going to assign to it. So some cases, if you need more than this, then PHP adds this extra OP data thing, which isn't an instruction. It's just a little bit of indication that, oh, we need some extra data for this opcode. And in this case, that is the name or the variable exclamation mark 0. And if you remember, that is the variable name that's being passed into the function. So that is the assignment itself. And then you have X statement again, because the debuggers like to stop on it. And at the bottom of every function and every method, there's this return statement. So because we hadn't defined a return statement in this function, you will get at the bottom return null. If you don't create a return statement yourself, this is what PHP does for you automatically. All right, so this is a very simple assignment, right? It just does assign a value of a property to a property. All right, I have 50 minutes left. Oh dear. All right, so let's have a little bit more a look at this, because the title of the presentation is all about the goto, and I haven't spoken about gotos at all yet. Right, so an if statement. An if statement is a decision-making point. The statement either gets executed or doesn't get executed, depending on the condition or the expression that you have in your if statement. That should be simple enough. So if we look at the AST, well, we see this if statement, and the if statement has elements in there. So if you have an else if, that would be an extra element in this list. But in this case, we only have AST if element. So the condition is a binary operation. We're comparing the variable a with the constant value 42. That is what this condition says here. That is what this thing does. And of course, if it matches, there are statements that belong to this clause, and the expression is basically an echo of a string that I forgot to close with double quotes, but that doesn't matter. So that's what this if statement does. Now, if you look at the opcodes that belong to this, and I'll ignore the X statements because they don't really do anything, but the opcode here is equal. So what it does, it compares the variable a, in this case, with the value 42, and the result of that, it stores in this temporary variable 1. That doesn't have a name to it, it's just an internal temporary variable. And then in the next operand, it actually checks whether that is true or false. So the jump z stands for jump 0, which means that if the value in the temporary variable 1 is 0, we're going to jump to 5. And 5 is the opcode down here. So that basically says, if the statement doesn't match, we jump over the statements in the if statement. That's what you want, right? If the condition doesn't match, we need to skip that bit of code. And this jump instruction, that is your goto. It's your first goto that you'll see. Now, if it does match, it doesn't do the jump, and you get this echo to the life, the universe, and everything. So that is how the first jump instruction works. So that's if. Now, an if with else, as I said, you have, again, this if statement here. That's pretty much the same. And then you have a second element, which is if elem, but it has an empty condition. The condition is null. Basically, that means it's an else statement. Now, if you look at this again, at what the opcodes do, is like, well, you get the is equal again. In this case, we're comparing it to pi. If it doesn't match pi, we'll jump to opcode 6. And opcode 6 is then nothing, but we need to be able to pause. And then it does the echo squares, and that's the end of the function. Now, if it would match, we're doing the echo for circles, and of course, we don't want to show squares as well, right? So there's an extra jump instruction after the first else, so after at the bottom of the if statement, that then jumps over the else statements in the clause. So now you get two jumps, two gotos already. You can guess where this goes, right? Anything that gets more complicated, you get more gotos, or more jumps. So let's have a look at some looping structures. So the for loop is kind of complicated. The for loop, you have a condition. So you have initial assignment, you have a condition and something that is being run at the end of every iteration. So you will see in the AST there's an init stage, a conditional state, and a loop state. And it's curiously, if you compare the order of that, so you have the assignment, the condition, and the increment, right? But if you look at the order of the opcodes, you first get, sorry, I need to look at the colors here. You first get the assignment, but then you get all the information from the elements in the for loop. Then you get the increment at the end of every array, and then you get the check for the condition. So the order that you see in the script doesn't match the order in the opcodes itself. Now, this looks a bit complicated, but it becomes more obvious if you actually rewrite your for loop with gotos. Now, I don't recommend you ever do this, because it makes it a lot harder to read, but internally that is actually what happens. So the way how PHP looks at this for loop is that, well, it first does the assignment, then jumps to the condition. But the condition is done, is recorded after the statements. Why PHP does that, I don't know. It is probably a little optimization to have a better flow or something like that. Then in the condition, it needs to check this thing, and there's this, I've used this dollar, it's difficult to see, it's the dollar underscore. That's my temporary variable, and then I match to check whether that's true, and if it's untrue, it goes to the statement, meaning that, well, we live one more iteration. We do all the statements in here, and then we do the increment of I, check the condition again. If the condition matches, we go back to the statement, execute the statement again, increment the loop. If not, then it just continues further on. And if you rewrite your for statement like this, the order in the opcode is exactly the same. So PHP does internally some rearranging to make things easier for it. Now you get the same thing for a while loop. So a while loop and a do while loop are very similar, right? The only difference is here that in a while loop, you do not necessarily go into the loop, but in a do while loop, you will always hit the loop exec once. And the only difference between that, if I switch between them, is, oh, no, not the for each, is this extra jump statement. So instead of doing the statement first in a while, it jumps over it to the condition, whereas in the do while loop, it doesn't need to do that jump. So because it always does the statements in the loop at least once. I'll publish those slides online so you can go through these two examples yourself later if you want. And if you have questions, I'm happy to answer them. But I want to have a quick look at the for each as well. And the for each statement is a lot more complicated. And I will explain you why, because of some of the complexities with things like for each loop, a goto statement in PHP itself can only be used to jump out of a looping structure, not into it. And it can only go to higher levels, not into things. Because, for example, if you have this for each loop, right? The for each loop, we first assign an array. That's the opcode down here. And then for each, there's done a reset that basically says set the internal pointer to the first element of the array. That's what it does. If it doesn't match, then we jump, if there's no elements in the array at all, we jump immediately to opcode 11. So we don't have to do anything else. After it's been reset and there is no, and there's elements in the array, we then do a fetch, and the fetch basically retrieves the key and the value. Well, the fetch doesn't. The fetch only gets the value, but the next operand does the key. Again, if it can't do this, it will jump to number 11. But the things in green here is something that has been initialized specifically for the for each loop, meaning that because some internal structures have been created, at some point you will have to free that. And that happens in the FE free at the end of the for each loop. So if there's no more elements, which is what the FE fetch does, it fetches the element and then goes to the next element, it will then jump to number 11, which is then here you FE free. Now, what would happen if you would jump into this loop with a goto, goes all well, but when you go to fetch the next element, it tries to fetch this from something that hasn't been initialized yet, right? And if something isn't initialized, that usually means you get a crash. Something crashes and a stack fault. So this is the reason why you can't jump into for each loops. This is sort of the only exception where you can't really do this, but to make it more consistent in PHP itself, you can never jump into any sort of loop or if statement because of this kind of reasons. All right. So, of course, when you get more for each loop and more nested stations, it gets really, really complicated, right? If you've ever seen the film Primer, then the loops get difficult. So luckily, VLD can actually show you the graphs as well with an option. So it will link the operand numbers, so which are the opcode numbers that you see here, and the line numbers. And it creates this nice graph on it so that it makes it lots easier for you to follow if you're interested in doing this kind of thing. This kind of dumps are really useful if you're working on internal PHP things, maybe on the op cache to debug some things and things like that. And it creates nice graphs, which is always good to show in presentations, as you know. All right. So another thing that you can do, if you have these graphs, you can find out where there is some code that can never be reached. Like if you do something silly like I have on this slide, right? So I have this if statement, I echo 40, I return, and then I do echo 2. Of course, logically, you can never hit those echo 2, right? And VLD, and also OP cache, PHP's opcode caching, will detect this kind of statement by trying to follow all the possible paths through the function, through all the opcodes, to figure out which opcodes can never be reached. In the case of OP cache, it will then remove those from the op array, doesn't have to store it, and that saves time and space, which is a good thing to do. So this finds unreachable opcode, which is really handy as well. Xdebug's code coverage functionality will also make use of this to tell you which codes cannot be executed. So PHP Unit's visualization of a code coverage report where it shows you some lines can't be executed, that comes from this analysis of all the looping that are possible to do. All right, that's what I had to talk about. A quick recap. So we looked a little bit at all the different stages. We looked at the stages, well, we have some code that you've written down in your editor. It gets converted into these tokens. These tokens are parsed by the scanner into this AST, this logical representation of a PHP script, which then gets converted to this bytecode, to these opcodes that PHP's engine can execute. All the looping structures, and of course I didn't cover all of them because I don't have enough time, but they are all implemented basically by jumping around this single array of opcodes. That's where your gotos come from. We looked at a little bit of code analysis for fun and profit. Well, fun maybe, profit probably not. But so we go. We looked at a few of the tools. So there's this tokenizer extension as part of PHP. There's Nikita's AST extension that you can find on his GitHub. There's the Packle extension VLD for you to look around what PHP internally generates. If you ever find a bug in Xdebug's code coverage, I'm going to ask you for just the code of the script, because sometimes I do this analysis wrong. And if I do it wrong, then the code coverage reports are not always correct either. So this helps me trying to track down bugs or usually changes in PHP between minor versions that do something else with the structure that I then need to make work again. So VLD is very handy for me with that, and especially when things like OP cache come into play, because OP cache also reorders things sometimes, which then Xdebug doesn't understand, and so on and so on. So that's what we have looked at. We have probably 5 minutes for questions. So if you have any, it would be great. There will be a microphone being brought to you, I'm pretty sure. When you're thinking about the questions, I have one more slide. I will put the resources, the slides as well as the resources on my joined in link, where you can also leave feedback for my talk. I'd be very interesting to hear what you have to say about this talk. If you want to do it in French or Dutch or Norwegian or English, that's all fine. German, maybe not, but any other language you want, you can put in there. I know how to operate Google Translate. If there's any questions, I'm happy to hear them right now. I can't see you very much though. Are there any? Need to shout though. Yeah, all the way to the top, well, sort of all the way to the top. 80% to the top, on the right-hand side. It's very difficult for me to see over there.
Thank you very much. At what stage are the errors handled?
So the errors are, so there's two different types of errors in PHP. So they're parse errors, they're handled in the scanner phase. So anytime you make a syntax error or you have things in the wrong order, that happens in the scanning stage, where the tokens are converted or trying to match with logical rules to this AST. So the logical rules implement all your parse errors. If you have runtime errors, they're done while PHP is executing the opcodes. So if you try to access a variable name that doesn't exist or hasn't been initialized, you get notices for that when PHP goes through the opcodes. So that's why this happens. Right next to the microphone, that's handy.
Thanks a lot. I wonder, maybe you showed it to us, I didn't notice, but is the goto statement in PHP corresponding to a special operation in the OP code, or is it a jump Z or something?
It will get translated into a jump, not the Z, just a jump. So there's different jump instructions, like there's jump 0, or just an unconditional jump, or there's a jump 0, not 0. So if it is 0, we jump to something. If it's not 0, it jumps to another opcode. So there's different versions of that jump instruction. But just the goto is a jump without any sort of condition attached. Yeah. All right. Anything else? Yeah, right there in the middle. It's closer for the microphone. You can go next.
Hi there, Derick.
Hi.
I was wondering how the functions like scandir that goes into the computer file system, how does that work?
So scandir is something that is just a function call for PHP. It's a function call into PHP's internals with some arguments. So that does not get reflected back into any opcodes, because this is an internal function that you haven't written yourself. So if you haven't written anything, the implementation of the scandir function it doesn't get reflected in the opcodes because it's just a functional implementation in C that is part of the PHP engine. And that is then responsible for looping over the file, opening the directory, the script, and looping over the files. You won't see that back in opcodes at all, ever. All right. There was one here in front.
So last question.
Last question. If you have any more, feel free to come and find me. I'll be hovering around on the tables outside.
Hello, thank you. Yesterday morning, I think we heard that the switch statement in PHP 7 was now implemented with the hash map. So my question was, how was the hash map implemented with jumps?
All right, so what happened in PHP 7.1 and earlier, a switch case statement was basically translated into an if, else if, else if, else if, else if, right? So if you have like 50 elements and the most likely, the most one used was the bottom one, it still have to all those 49 comparisons every single time. So in PHP 7.2, that changed into a hash map, meaning that when the scanner stage happened, the construction of the AST, the translation of the AST is now done no longer translated into it is still translated into the if-else statements, but an additional check is done where a jump table is constructed, and the jump table has if it's a normal array, it has the array index and the jump location immediately in this table. So by doing this simple hash lookup, it can jump immediately to the right opcode. So that is a big improvement that's new in PHP 7.2. However, it still needs to have the fallback of all the if-else statements because the hash map is only used, is only used when the type is either a string or a number. So if you pass in a Boolean, it doesn't necessarily know what to do with it, and then it will still have to do all the if-else statements for it. So there's an optimization where the exact type, a number or a string, is used in all the different case statements in a switch case statement. So that's how that works. All right. Unfortunately, that's everything for now. If you have any further questions, as I said, feel free to find me. Happy to answer. I'm going to have to evacuate the stage for the next speaker. I hope you enjoy this and enjoy the rest of the afternoon. Thank you.